So in this video, we're going to use a half-angle formula to calculate the sine value. This is one we've actually done in a previous video, so we'll also be able to compare the results of this example with the previous one. So, I didn't do this in the previous example with a tangent value, but it doesn't hurt to go ahead and just give the identity so that it's a little more straightforward to work this out. So we have the identity right in front of us. So plus minus square root of 1 minus cosine theta over 2, that is the half-angle formula for sine. So what I need to do is take this guy and think of this as being half of some angle theta. I'm not told what theta is to start with. I'm told what half of, I'm given an angle and it's half of something. I have to figure out what that something is to use in the formula. I'm going to have the whole theta there. Whereas the angle that I'm asked about is half of the angle that we end up using. So this equals, well, basically if I double the angle that I'm given, if I take 5 pi over 12 and I multiply by 2, and I can reduce the fraction that way, well, I get a number where if I take half of it, I get 5 pi over 12. So 5 pi over 6 over 2, that is going to be equivalent to 5 pi over 12. Okay? This is just arithmetic. Maybe this is straightforward, but I want to make sure this is as clear as possible. How do I figure out what to put in to this identity, right? So this means that theta is 5 pi over 6. Okay. So that means that sine of 5 pi over 12 is equal to, well, plus or minus, which we'll address in just a moment, the square root of 1 minus cosine of 5 pi over 6. Okay, all over 2. Well, not all over, but inside the root. So I'll leave the plus minus as is for now. We'll figure out which one to use in a moment. So plus minus square root. So cosine of 5 pi over 6, that is negative root 3 over 2. So I have 1 minus negative root 3 over 2, all over 2. Okay. So again, we'll leave the plus minus as it is. We'll deal with that in a moment. So this is the square root of 1 plus root 3 over 2 over 2. And as we did in the previous example, I'm going to multiply inside the root by 2 over 2 so that I can cancel this denominator here. When I distribute this 2, that will simplify the numerator inside the root a little bit. So this is equal to plus minus square root of 2 plus root 3 over 4. And that's about as simple as it's going to get. We have a root inside of a root, which is kind of messy, but we're kind of stuck with that. So now we need to talk about the plus minus. How do we decide? Well, if you think about where 5 pi over 12 is, one way to deal with that is, let's make a unit circle. Close enough. It's off kilter, but whatever. So 5 pi over 6 is like right over here in quadrant 2, right? So what I want you to think about is the following. If I'm talking about half of this quadrantal angle, if we go to pi over 2 and I take half of that, well, that's going to be here, halfway up to that point, right? This space here is equal in quantity to this space here, right? We're cutting the angle in half. So if you're cutting pi over 2 in half, you know, with pi over 4, which is in quadrant 1. If I go to this quadrantal angle, pi, and I cut that in half, well, I get half of that, right? This, well, let me get a different color. This chunk here, this chunk of that angle is equal to that chunk of that angle, right? We're cutting the angle marked in green in half. So that would put us at pi over 2. So when I cut the one we actually have in half, I get something like right here, right? This amount of angle here is equal in quantity to this amount of angle here, right? So if you take an angle that's in quadrant 1 and cut it in half, you end up in, I'm sorry, I misspoke. If you take an angle that is in quadrant 2, right, like 5 pi over 6, You cut it in half, you end up in quadrant 1. Another way to think about that is, which you don't need to draw this out, I just think it's helpful to do so. If you have 5 pi over 12, you need to think, well, which two common angles is it between? And it's not too hard to see that this, of course, is greater than 0, of course. But this is less than 6 pi over 12, right? And 6 pi over 12 is pi over 2. So we can conclude, oh, well, that means 5 pi over 12, that is between 0 and pi over 2. Well, that's quadrant 1, right? So I know I'm in quadrant 1 where everything's positive, so I can backtrack and go cross out all of these minuses. It was never minus at all. I just didn't know that until now. So there's my solution, which I guess I'll write again. Sine, it was sine, wasn't it? Yeah. Sine of 5 pi over 12 equals the square root of 2 plus root 3 over 4. Okay, that's the result that we get. Now, as I said, we can compare this, I copied it here, from a previous example. You know, these sure don't look the same, do they? They kind of look related, but not, they don't look equal, right? They definitely look different. It turns out they actually are equal in value. One way to see that is throw each of them in a calculator. You get decimal numbers that are decimal approximations that are the same decimal approximation. You can also do this using arithmetic by hand. It's a bit tedious. So if anyone wants to see that done, I can do that. I just don't want to do it right. This video is long enough, so I don't want to do it right now. But basically, yeah, we get the same value, just looks different. So this might be more complicated or less complicated than the other version. I guess that depends on your perspective. But that's how to use the half-angle formula for sine to get a value.